Thank you, Terry. So I'm very happy to be here. So on behalf of Elsevier, also welcome. I must say it feels a bit like we are in a wedding ceremony in this chapel. So maybe join me to wed maybe e-science with science policy today. So I will talk for 15 minutes, it's getting shorter and shorter, about the world of research. What are the main drivers? I will talk about 4 trends in the world of research. There's a key theme here is 4. And then about the 4 contributions from the STM, science, technology, and medical information companies to this world of research. So first, research, it's pivotal to economic growth and addressing societal changes. So we work together with the Royal Society. We published a report called Knowledge, Networks and Nations. And just some quotes, they see that science is the key to achieving long-term economic and social development. It's crucial to economic competitiveness. So very encouraging. Also, the world of research is large. We're talking about 1.2 trillion US dollars, so maybe even more in Australian dollars. And here you already see the number 4 coming in again. It grows with an annual growth rate of 4%. So all this R&D spending as percentage of the GDP has been relatively stable. If you look, it should be 4%, but unfortunately it's a little bit more than 2%. It's growing up slightly for the developed markets, and for the developing markets it's actually growing. So very good news there. What we see, for instance, that government, even during economic crisis, they invest more in research. So the NSF budget went up while there was an economic decline in the US. Japan shifted money away from nuclear energy to science, a very logical step. In Europe, lots of EU funding used to go to the farmers. Now it's going to researchers. So research and R&D funding is well protected. So if you invest all that money, so how does it end up? So we see that the number of researchers is going up, and surprisingly it's also 4% by every year. And also the number of research articles is going up by around 4%, which you might think, researchers publish more articles and there are more researchers, so it should be higher, but in fact it's also by the same 4%. Now, all this input of money correlates very well with the output of number of articles. So you see that here, and I also put a little arrow where Australia is, right there, so you cannot miss it. So it's a very close correlation. The more money you put in R&D, the more articles you get out. So the 4 trends that continue to increase the value of research information. And the first one is interdisciplinarity. The second one is collaboration and mobility. Then the third one is the emerging markets. And the fourth one is data intensity. So let's look a little bit more closely into all of them. So what we see here is that if you look at science, it's becoming far more interdisciplinary. And it also means that we have to perform science in a different way. You cannot be only a chemist and know everything about chemistry anymore. You must know about other fields, biochemistry, for instance. I show here what we call the map of science for Australia. Every circle you see here is an area where Australia as a country is outperforming other countries. And the different colors are different subject areas. If I stand here, you won't hear, but you can. So this is, for instance, chemistry, engineering, and the biological sciences. So you see that there is this nice cluster where Australia is doing really, really well, and that is in the area of biotechnology and biology. And what this methodology allows us is to also look at interdisciplinary sciences. So if you take a cluster in the center, it has contributions from different subject areas. And so we see that this has become more and more important, and this service that we provide, we can also help you kind of identify what are the interdisciplinary areas where you as a country are outperforming other countries, or you as an institute are outperforming other universities. Oh, sorry, skip one. So we also see that research is increasingly international and more collaborative. So if you look between 1996 and 2008, we see that the percentage of internationally co-authored articles increased from 26% to 36%. There's a little bit of a messy graph here, but essentially what you see is in an absolute number and in a relative number, if you look at the number of articles that were internationally co-authored, so all countries go more or less up, which is in this direction. Some countries make a little bit of a strange move, like China, because for a while they published more articles with only Chinese co-authors, but you see the general trend is going up. So more articles are written with co-authors outside of their country, which means it's more important now to have an international outlook. If you run a university, you must think very deeply, do I have the right collaborators? Do I work with the right institutes in the different countries also? And that's also something where Elsevier is thinking, how can we support that process? Another trend is that the emerging markets, they are rapidly growing in their research activity. So here I list the growth of the number of articles. And what you see is that the real growth comes from China, growing 20%. It's, you know, an incredible number. India, 11%. Brazil, 13%. So this is the number of articles. South Korea, 12%. And then the more, you know, the established powerhouses in the US, UK, Japan. So they're growing around 4%. Japan, 2%. So, you know, much lower than the world average of 5%. And the rest of the world is then at 3%. So we see that it is really a shift from, would I say, the Western established science nations to these emerging science nations. By the way, I couldn't find the exact number for the last 10 years, but for the last 5 years, Australia has been growing at 7.7%. So you're close to, you know, the emerging science nations in that sense. We also see that research is increasingly data intensive. So here is a graph where we asked researchers for the different types of information. How easy is it to get access and how important is it to get access? So if it's very important, then it's on this side. Is it very easy? It's up here. So for research articles, and that's very encouraging, it's very important, obviously, and access is very easy. Now what is crucial here is data sets, data models, algorithms, programs. It's quite important for researchers, but they have problems getting access. And we all know that, you know, the researcher will say, yes, I definitely want to have access to all other people's data, but there are very good reasons they don't get access to my own data. So this is an area where we look much closer into. So the science, technology, and medical information companies, we feel they have a unique vantage point on research. Just you know, to give you some numbers, each year there are 3 million articles submitted. We use the help of 300,000 peer reviewers. In the end, you know, half of them survive this peer review process and are published. We have 30 million readers worldwide. 2 billion articles are downloaded every year. And also there are 30 million citations. So very big numbers, and it gives us a very good perspective on what's happening in research. So going into the 4 contributions now. The first one is that we continue to register, to review, to disseminate, and to preserve the research outputs. So can you imagine if there was no peer review and there were just scientists making claims and nobody was going through this quality process? So this is where I think the publishers, you know, make a unique contribution. The second is that we also are involved in supporting and nurturing the cross-disciplinary research areas. A good example here is we have articles in The Lancet, which of course is a medical journal, but it deals here with managing the health effects of climate change. And that is also covered in lots of other journals, greenhouse gas control. So that's where we can support by either having interdisciplinary topics in journals or having interdisciplinary journals. We also facilitate collaboration. This is from a report that we did for the UK government, and we looked at for the UK, who are they collaborating with? And we see the larger the circle, the stronger the collaboration. So, of course, USA is number 1. The colors denote countries where if it's green, they have a higher impact than the UK. If it's yellow, it's lower than the UK, but still higher than the world average. And if it's red, then it's lower than the world average. And of course, UK is also collaborating with Australia here. Another area, and it's a bit of a messy slide, but I will explain it to you. We can also help where we talk about brain circulation. So before we started this study with the UK government, they said we suffer from brain drain. So we looked at the researchers that left the UK, that came into the UK, that stayed, and the researchers that were just visitors. And if you look at productivity, the interesting point is the people that leave, so the average productivity for all of them is 1. So the people that leave the UK have a productivity of 0.92. The people that come in, so that is not the opposite to brain drain, have a productivity of 1.14. The people that come for a short stay have a productivity of 1.24. And the people that never leave have a productivity of 0.6. So I think brain circulation is very healthy for the UK. We are also very much involved in facilitating access to experimental data. So the publishers that are working there to facilitate access, so access from our publications to data sets. These data sets could be with the publisher, hopefully the smaller ones, not the output from the Large Hadron Collider. But we also link to very large data sets which are in data centers. And we have all types of linking. We can have link for an article. We can have link from an entity within an article. We also have now 100 apps like you have on your iPhone. We have those also for on our own platform. They also can facilitate on-the-fly linking between publication and data. In summary, I think I'm doing very well with time. So the key point I want to make is what drives quality research is quality information. And what drives quality research is then also, in the end, the quality of life and the impact on society. So thank you very much, and I'm ready to take some questions.